Hello, and welcome to yet another Infilink video tutorial. In this video, we are going to check out scripting in Infilink. Infilink uses basic, like language to implement scripting. You can do arithmetic calculations, carry out conditional actions with if, then, else, and if, like structure, and do much more with Infilink scripting. Scripting in Infilink makes it very flexible, and you can design your SCADA or HMI projects the way you want them. In this video, we will just have overview of scripting. I will come up with separate videos or very advanced script commands in near future. So let us get started. In Infilink, scripts can be attached to objects. You can attach scripts to following objects: project, HMI window, graphics shapes and objects, tags, alarms. For project, 3 separate scripts can be attached. The project open script is executed only once, when the project opens. While project open script is executed repeatedly, at predetermined time interval, while the project is running. Project close script is executed when the project closes. Similarly for HMI window, 3 separate scripts can be attached to each HMI window. On window open, script will be executed when window opens. While window open, script is executed repeatedly, at predetermined time interval, till the window is open. On window close, script is executed and window closes. For graphics shapes and objects, the attached scripts are executed on left mouse button, click event. Attached scripts are executed at mouse left button, down and up events. While left button pressed, script is executed repeatedly at predetermined time interval, while the mouse button is kept pressed. You can also define unique keyboard key combination, which when pressed, will act as mouse click on that object. For memory tags, the attached script will be executed whenever tag data changes. For OPC tags, the scripts are executed at following events for that tag. When the initial value is received from the OPC server, when the tag data changes, or when tag enters error state. For alarms, the attached scripts will be executed on following alarm events. Alarm becomes active. Alarm is acknowledged. Alarm becomes inactive. Script can also be repeatedly executed at predetermined time interval while the alarm is active. Thus, you will notice that Infilink provides you lots and lots of options to implement your control logic for your HMI or SCADA project. Now, let us see these scripts in action. We are going to use this little Infilink project for this demonstration. Data change scripts are very simple to use and are very effectively used in Infilink projects. Data change script is attached to a tag, and whenever the tag value changes, that script is executed. In this example, I have 3 tags representing 3 tank levels. These are level 1, level 2, and level 3. I am interested in knowing total of these 3 levels in real time as the levels change. I have created a tag representing the total of levels. I have attached a data change script to each of these 3 level tags, which calculate total of these 3 levels. Let us see how these scripts are attached. We are seeing here the script statement, which will be executed every time the data of this tag changes. Exactly same script is attached to remaining 2 level tags. So whenever any one of the levels changes, the value of total level tag is recalculated, and hence we will see the total level updated in real time. Infilink script is a collection of statements like these. You can have many statements in a script. the limit is 30,000 characters per script, which is quite a large number for a script. Each statement is terminated with semicolon. Comments can be written by starting the line with #character as a first character on that line. We will check out more about script syntax and commands in more detail later. I can use a bigger editor, which also do syntax highlighting. That makes reading big scripts very easy. Now let us go to run mode and see these data change scripts in action. We are now seeing that as the liquid level in any tank changes, the tag representing total level is updated instantly. In the next section of the video, we will see one more example of usage of data change scripts. In this example project, I am getting liquid level from outside, and I am interested in knowing the liquid volume in real time. As this is a demonstration, I am generating liquid level change with a slider object. The tank is a cylinder and the diameter of the cylinder is known. I am using liquid level and cylinder diameter to calculate liquid volume in real time. With these two examples, we will have a good idea about how these data change scripts can be effectively used. I am using memory tags in these examples, so I can attach script that is executed only on data change. But in real-world projects you will be using OPC tags, and you will be getting values from PLCs or other devices. For OPC tags, you can attach two more types of scripts. The script that is executed when first valid data is received for a tag, and the script whenever the tag goes into error state because of some communication failure. You can take appropriate actions on those two extra events, which can occur for OPC tags. In the next section of the video, we will check out scripts those can be attached to alarms. To demonstrate the alarm scripts, I am going to use this Infilink project. I am using this slider object, which changes the value of OM tag. High and low alarms are defined for that tag. I am going to count following, using scripts attached to alarm events. How many times high alarm occurred? How many times low alarm occurred? How many time alarm was acknowledged? I am also going to check out how much time any alarm is active. Similarly, I am going to show the status of the alarm as a string tag. Let me show how this is achieved by attaching scripts to various alarm events. In your real-world projects, you probably will be requiring many other actions to be carried out on these alarm events. For example, you may want to write a text file capturing related tag values and the alarm occurs. You may want to send an email when the alarm occurs or when it is acknowledged. The possibilities are many. Infilink scripting, with its event-driven architecture and variety of script functions, will most probably satisfy your requirements. Now let us run this project and see this in action. In the next section of the video, we will check out action or button scripts, which can be attached to buttons and other graphics objects, which are executed on mouse left button clicks over those objects. You can attach scripts to almost all graphic shapes or objects. These scripts are executed and the mouse click happens over that object or shape. You can attach 3 different scripts to the object. The script can be executed and the mouse left button down or left mouse button up event occurs. Third kind of script can be executed repeatedly at set time interval and the left mouse button is kept pressed. In this demo project, I can change the temperature setting by pressing plus or minus buttons. I will keep the mouse button pressed on those buttons, and the temperature setting will keep on increasing or decreasing by small amount till the button is pressed. This is achieved by attaching, while button down, kind of script. For reset button, I have attached on button down kind of script and resetting the setting to 55 degrees. Notice that I can also define equivalent keyboard key combination for each of these objects. So the same actions can be carried out by pressing keyboard keys instead of mouse. Please also notice that I can define minimum access level to these object scripts. If the minimum access level is defined, and if it is greater than 0, then the button can be pressed only when user with higher privilege level is logged in. Now let us switch to run mode and see these button scripts in action. In the next section of the video, we will check out project and window scripts. Scripts can be attached to project object. These scripts will be executed on following events. When project opens in run mode. While the project is running. When the project stops running in run mode. Script is executed at certain fixed time interval when the project is running. Similarly, scripts can be attached to each HMI window object. Let us quickly see the attached scripts to the project object and window object and see them in action in run mode. By now, you must have got a good idea about Infilink's scripting model. In the next section, you will briefly check out what kind of functions can be carried out with Infilink scripting and what scripting commands are available. Infilink provides operators and functions to carry out basic math on integers and floating point numbers. Trigonometric and logarithmic functions are also available. Functions to manipulate strings like trim, ltrim, rtrim, and many more are available. You can read and write simple text files in ANSI and Unicode formats. You can also read and write CSV files. With play sound function, you can play back sound files. With speak out script command, you can do text to speech. You can send emails from within Infilink. You can also launch other Windows applications from run mode and control them by sending keystrokes to them. We will check out some of the more complex functions in detail in subsequent videos. Hope you have got a lot of insight into Infilink scripting. Thanks for watching this video, and bye for now.